Greetings. Welcome. So, a couple of videos ago we did a battery test, and we got like a whopping 30 to 35% of the energy back from the spike off of the drive coil. So we're going to do that again, and I'm hoping this time to do better than that. And it's a very low bar, so I think we'll do a little bit better. The effort was not without some missteps. I blew the thing up initially, but eventually I got it to run, and I'll just tell you it did a bit better. Not like, 350% or something like that, but it did a bit better. Now, I'll also say, and I shouldn't pay any attention to any of this, and I try not to. But the last video, the video I thought would get no views, where I'm like saying, here's Andre Ampere's theories. And at the same time, I'm talking about something unrelated, where I'm saying, I'm spinning a rotor real fast. That one got like as many views as I've seen in a long time. And I can't tell whether it was because I was talking about this highly theoretical work of Ampere from over a century ago, or whether I'm saying I'm spinning a rotor real fast. So, I mean, I think if I want to grow the channel from now on, it'll be like, origins of Newton's calculus and blowing up a giant bag of sand. So, I'm being silly. So I don't know what was going on with that. People like that video. But if people are interested, as I try to plow through the 528 pages, I'll look to comment on things that I find interesting, and if people like that, you can mention them in comments. Keep on with the theory stuff. It is 528 pages, and as David Byrne of the what was it with the Talking Heads sung, "I'm wicked and I'm lazy." So I'm not sure how long it'll take me to go through that, but just going through the first 30 or 40 pages, they're even just talking about terminology now. So since I'm kind of on the soapbox and BSing, and it's sort of like I never knew exactly why they talked about electrostatics. What does that mean? What is electrostatic energy? And what I finally decided was it's just electricity that's in a capacitor. But that's not really what they were getting at. You got to go back to the source and look at the people who first used the term. It was Ampere that first used that. And what they're getting at is, if you have 2-point charges that are stationary, there's still a force. If they're positive, negative, they're attracted. If they're positive, positive, they're repelled. Just like if you have two magnets that are stationary, depending on the polarities, they attract or they repel. However, when you put two charges in motion relative to each other, there's a different force than the electrostatic force that comes into play. So now it's like it's all much simpler. And then, to go from there, since I'm talking at you, there's the second order derivative, where if there's a change in the rate of current flow, even just one current in a coil, then something really odd happens, is that there's this electromotive force, or yes, an electromotive force upon which current can flow. So current flows from the ether, wherever it comes from, when there's a change in the rate of velocity of current. And that's kind of significant because that's what we do with the battery test. You hit the drive coil and it collapses. There's the rate of flow of current is, we're trying to change it as quickly as possible to get as much of that displacement current or radiant spike or whatever you want to call it out, which is, as I said, another effect, a second order derivative effect. And again, I'm just BSing here, but you wonder, is there like a third order derivative where if there's a change in the rate of acceleration or deceleration, is there like another phenomena? It's like light or anti-gravity, or you like teleport to the other side of the planet or something. But again, I don't know why people like that video. It might be because they said I'm spinning something really fast, or it might be that they're people want to hear about this work with Ampere, and I am going to plow through it. It probably will take me some time, and I hope I make it through the whole thing. But anyways, without further ado, the conclusion. No, it's not the conclusion. There's going to be a number of these, I suspect. The second battery test.
Greetings, welcome. So, you might be happy to know I blew up my machine. Hopefully you're not happy. But I blew all the switches. I was getting all excited to do another battery test, and this time I was going to run it at 27 volts because I seemed to get a bit better efficiency there. And had the 27 volts, went to spin it. The gray smoke. I elected a new pope. And so the reason that's happening is that, once this thing is spinning at speed, it's only drawing about 50 milliamps, which is, I thought that's pretty reasonable. 250 milliamp hour batteries get your answer in 4 or 5 hours. When it first starts off, though, that 50 milliamps is, well, it had to be over half an amp, because that's what the last ones, Comasay C37s, I think they were half an amp. So it was probably like an amp, and that's why you have a problem. So, well, the first thing I'll mention is I've got it running again, as far as I can tell. And you'll notice that those are no longer black. Those are 4 white switches. And those are, I believe, 80 or 100 volt AC solid state relays. The previous ones were 60. So that it's actually, kind of a silver lining on the cloud is I can now go up to 40 or 50 volts. But the thing is, how do you prevent that from happening again? So I dug this out of the closet, and this, of course, is a potentiometer. And so right now it's got 1 mega ohm of resistance. If I turn it all the way the other way, it goes down to about 1K. So what I'll do when I get the batteries in is run it through the potentiometer and gradually turn that up. And then once it's spinning, I'll remove the resistance. So here I'm just spinning it up at 28 volts. It's making some noise, but hopefully that'll calm down. There's not a whole heck of a lot of vibration. Good spike. And see, we're only drawing 60 milliamps. That'll probably go down to about 50 once it's fully spun up. Then, before I put the batteries on, what I'm going to do is run it through the potentiometer, chop the amp draw down to like 1/10, and then just start it cold at 28 volts and make sure I don't blow up any switches again. It sounds like an airplane. So here it's spun up at 28 volts. I'm going to have to make sure that that noise isn't any tape flopping around. It's 1740, so not too fast. 1739, 1730, right around there. The spike through 10K ohm is 98. I'm going to just jot these down. So if we throw these in the spreadsheet, we can see with that 28 volts, drawing 54.4, there's your milliwatts you're expending. Your spike is 98 volts across 10 ohms. There's your milliwatts out, so you should get 63% back. And that's why we're going to do the battery test. I'm going to skip anything with the pickup coil right now. You can do a bit better, but I don't want to complicate things. The question I'm trying to get to the bottom of is, when you're measuring this across a resistor, when I do the battery test, is it again going to show up, just getting back 25 or 30% of the capacity? Or is it going to be 60, 65%? Or maybe it'll be better. So I don't know. But I think that's kind of important just to figure out whether I'm measuring anything relevant. Alright, this doesn't really work because that's a 1 mega ohm resistor. And so no matter how I turn it, it's either basically fully on or fully off. I need like a 10K or a 1K pot, which I don't have. So we're going to go to plan C. If that doesn't work, we'll go to plan D. So plan C is just what happens if I think this is a 1K ohm. If I just throw that in there, will that work? Plan D will be spin it up with power supply. Once it's spinning, then change over to battery power. But let's see about this. Okay, right idea, wrong resistor. 100 ohm. Do that. Start at 28 volts. Nothing's blowing up, and it's going to spin faster. So then you let it spin up as fast as it's going to go here with batteries, and then you switch over to no resistance. Okay, so after the first abortive attempt, we got 2 sets of 3 batteries in series hooked up. They're all going to the leads on the power supply, and then the leads on the power supply go out to the bridge rectifier. So the bridge rectifier should charge these batteries. It's sitting at 25.4 or 5. We'll call it 25.5. That compares to 25.2 before, and we had 28.38. It's down to 27.92 when I blew up the switches. So I'm going to put that in. Okay, so this is the more important end, and as long as I didn't hook anything up wrong, it shouldn't blow up. So we got the negative bus from the circuit going to here through 100 ohms to here to negative. Positive is going from here to here. When I hook this up to there, we'll have the 28 volts through the 100 ohms, and it shouldn't blow up when I spin it. This isn't doing anything now. When it's spinning, if we want, I may or may not, we can check the amp draw, but we kind of know the ballpark figure of what sort of milliamps it's going to be drawing. So away we go. Okay, that part. Don't blow up, you. Yay. Wonderful machine. I can hear it spinning faster. Let's see. Yeah, the spike's going to stink initially because it's going through all that resistance. This has worked. That's going down slowly. This is going up slowly. In about another minute, we'll get rid of the resistance. Okay, I actually think it's spinning fast enough. And we want to see this go up. I hope I have this end hooked up right. So what do? We get rid of this. We get rid of this. Come on. We do that. Yeah. So this end is working as well. Nothing's blowing up. And this thing's starting to take off. Yeah, it's up to 26.2 now, so that's working. Let's shut that off. I don't know if you need to do this, but I might as well. The next question is just, hopefully it's not going to rattle apart. Alright, we're coming up on 15 minutes. It's going to take like 4 or 5 hours, so I'm not going to check in every 15 minutes. But we're spinning at 1792, which is a little faster than off of the power supply. Our run batteries have gone down to 26.57, so they've gone down 1.35 volts. Our charged batteries are at 27.1, so they've gone up 1.7 volts, but there's 2 sets of them, and there's only one of these. So if you're just going off of voltage, you'd say that's a COP greater than 2. In fact, I'll throw that in. So that would be a COP of 2.51 if you were going off voltage. I think this is what a lot of people often see, but what I also see, which I notice is very rarely done, is when you put a load on these, they don't have a capacity commensurate with the voltage. And initially I thought that was because of the one diode. I think it just has to do with pulse charging. So in other words, I don't know how this is going to turn out yet, but hopefully we'll get past that voltage for these 2 sets, and then we can at least start to hope for something decent. But as I said, I mean, unless I'm going to like sing 4 hours of Clancy Brothers songs at you, I think I'll just check back in at some key moments. Oh, of all the money that e'er I spent it in good company, and all the harm that e'er I've done, alas, it was to none but me. And all I've done for want of wit. Alright, that's not bad. Great song, Parting Glass. So let's see where we are at a half hour. Rotor slowed down, that kind of surprised me. And there we see the COP. To memory now I can't recall, so bring to me the parting glass. Good night and joy be with you all. Alright, we'll check back if this gets above or equal to there. So just a real quick update. We're an hour in and you can hear it's making a lot of noise now. Slowed down to 1716. So after an hour in, not only was that a great COP between a half hour and an hour, we're also, these 6 charge batteries are at 28 and the run batteries start at 27.92 and they're 26.16, so they're still over 8.7 volts in them. So you would think that means something great, but so far it hasn't. This noise I don't like, and what I think has happened is some of the electrician's tape that's holding this together is flying off, so I gotta shut it down and do the same thing I did before and hope I don't blow it up. None of the tapes seem to come loose, which is actually sort of more concerning, but let's spin it up again. Please don't blow up. I don't like this. There we go. Is it working? Well, I don't know what it was, but I kind of super glued down some of the tape. Let's quiet it down a lot, and it's sure spinning a lot faster. 1833, climbing. The fastest it was at before was 1780 and slowing down. So that I think is a good thing. Alright, just real quick. So another half hour. Thing's quiet as a mouse now. And it's spinning at 1835. And so this is at 26.15. It was at 26.16 a half hour ago. Now I think most of that is just because it's spinning faster. It's less of a load. In fact, it was at like 26.18 when this first started. It was spinning there. This is continuing to charge, so that looks really neat. These went up 0.2, all 2 sets of them. This went down 100th. So, and the other thing is we're at 9.4 volts now on all of these. You would think that would mean something. We'll have to find out. But this is not even close to, you know, what is that, 26.15. They're still above 8.7 volts. So I mean it's got plenty of room to run, and we're at 9.4 volts there, so let's see what happens. Not to bore people too much, but just another interesting point here, between 2 and 2.5 hours. The run batteries are holding up well, 26.09 to 26.01 over the half hour. Now here, you know, a half hour went up 0.1, half hour, or 0.2 rather, went up 0.1 over half hour there. So I was hoping another 0.1, and there seems to be another part to the battery charge curve because it went up 0.3. So now these batteries are at 9.53, and we got 6 of them, and we had 3 of them there at 27.92. They were at like 9.4. So this is definitely better than I've done before, and just have to let it finish its thing, and then put a battery on a load and see what it does. So when I say better, I mean I'd never gotten past 9.5 and we're up to 9.53. And these batteries, what's 26.01 divided by 3? 26.01 divided by 3. We're still, close to 8.7, and it's still, the voltage is dropping very slowly each half hour. So everything's looking good. All right, so there was a battery test. Here. I didn't test all 6 of them. I just tested the first one, but I think the other ones will show the same thing. We got back 49.56 milliamp hours, where if the battery was charged, it would be between 200 and 240 milliamp hours. Now, there are twice as many of them as the run batteries, so you say about 100 milliamp hours. And initially you would say versus maybe 220 with the charged batteries, except for I shorted this thing when I blew it up. So we were starting with maybe 200, you could argue 180 milliamp hours. So what I'm saying is the efficiency is between 50 and 60%. That's it. But a lot better than 35 and worse than that earlier. So moving in the right direction. Keep smiling. And good night and joy be with you all.